Have you ever wondered how batteries work? Why they are such an essential part of our daily lives? From the smartphone in your pocket to the electric car on your driveway, batteries are the silent heroes powering our modern world. But what exactly are they? Batteries, much like the elements around us, are fascinating electrochemical devices. They have the remarkable ability to convert chemical energy into electrical energy. But unlike disposable elements like dry cells, batteries are designed to be rechargeable. At their core, batteries are composed of three main components. First, we have the anodes and cathodes, the electrodes that are ready to jump into a chemical reaction at a moment's notice. Then, there's the electrolyte, a solution-filled separator that allows charged ions to flow between the anode and cathode, all while ensuring they never physically touch. So, ready to delve into the fascinating world of batteries? Let's kickstart this journey. First, let's understand the main players in a battery, the anodes, cathodes, and the electrolyte. Imagine a battery as a bustling city. In this city, the anode and the cathode are like two major hubs, while the electrolyte is the highway that connects them. Each one plays a unique role in the battery's functioning. The anode, our first hub, is the negative electrode of the battery. Think of it as the starting point. It's made of materials that are rich in electrons, ready to set off on their journey. When the battery is in use, these electrons are released and start flowing through an external circuit. That's the power you see lighting up your device. Meanwhile, the cathode sits on the other side of the battery, acting as the destination for these electrons. It's the positive electrode, and its job is to accept the incoming electrons. The material of the cathode is chosen for its ability to readily participate in these chemical reactions. Connecting these two hubs is our highway, the electrolyte. No, it's not a liquid as you might think from the name, but a separator filled with an electrolyte solution. This electrolyte allows charged ions to flow between the anode and the cathode, but it's also the peacekeeper of the battery city, preventing the anode and cathode from physically touching and causing a short circuit. So, in our battery city, we have a constant flow of traffic. Electrons start their journey at the anode, travel through the circuit, and reach their destination at the cathode. Meanwhile, ions are also moving, but they're taking the electrolyte highway from the anode to the cathode. Just as a well-functioning city needs efficient hubs and well-maintained highways, a good battery requires efficient anodes and cathodes, and a reliable electrolyte. Each player is essential for the battery to do its job, providing power when you need it. Now that we know who the main players are, let's see them in action. Ever wondered what happens inside a battery when you switch on a device? It's all about chemical reactions. Picture this. You tap a button on your remote control and suddenly your television springs to life. What's happening inside that little battery to make this possible? It's an exciting dance of electrons flowing from one end of the battery to the other. At the heart of it all, we have two main processes. Discharge, which is when you're using the battery, and recharge when you plug it back in. Let's break it down. During the discharge stage, a fascinating chemical ballet takes place. At one end of the battery, we have the anode. Here, a process called oxidation occurs. Think of oxidation as a generous act. The anode gives away electrons, which then rush through a circuit to power your device. While this is happening, positively charged ions in the battery are also on the move. They travel through a special solution called the electrolyte, making their way to the opposite end of the battery, the cathode. And what's happening at the cathode, you ask? Well, that's where a process called reduction takes place. Reduction is the other side of the coin to oxidation. Here, the cathode graciously accepts the electrons that the anode has given up. These electrons combine with the ions that have traveled through the electrolyte, resulting in a change in the cathode's chemical state. All this might sound like a one-way street, but here's the brilliant part. In rechargeable batteries, this process can be reversed. When you plug in your battery to recharge it, an external power source pushes electrons back into the anode. The same reactions that occurred during discharge now happen in reverse, allowing the battery to be used again. So, that's the magic that happens inside a battery. It's a symphony of chemical reactions, a give and take of electrons, a dance of ions. But did you know, not all batteries are the same? Different devices require different types of batteries. Let's explore some of the common ones. First, we have lithium-ion or Li-ion, the go-to power source for most of our handheld electronics. These batteries are favored for their high energy density, meaning they can store a substantial amount of energy in a small package. This makes them ideal for devices like smartphones and laptops that need a lot of power but don't have a lot of space. However, they do have a downside. They can degrade over time, especially if they're exposed to high temperatures, which can shorten their lifespan. Next up is nickel metal hydride, or NiMH. These are often used in standard AA and 8AA battery sizes. While they don't pack as much energy into a small space as Li-ion batteries, they still have a good capacity. They're also relatively inexpensive, which makes them a popular choice for devices that don't require as much power, like remote controls or some children's toys. Lastly, we have the lead-acid batteries, the stalwarts of the automotive world. These are what you'll typically find under the hood of your car. Lead-acid batteries are robust and excellent at providing short bursts of high power, which is perfect for starting your car's engine. However, they're not designed for frequent discharging and recharging, so they're not suitable for devices that need a constant power supply. Each of these battery types has its strengths and weaknesses, which is why different devices use different batteries. A Li-ion battery might power your phone, an NiMH battery might power your TV remote, and a lead-acid battery likely starts your car. Each battery type is tailored to the specific needs of the device it powers. So, now you know why your car battery is different from your phone battery. But how can we make batteries better? Battery technology is not static. It's evolving every day to meet our growing energy needs. Just as we're always on the move, so too is the world of batteries. Researchers and scientists are persistently pushing the boundaries, seeking out innovative ways to enhance the energy, density, lifespan, and charging times of batteries. It's a fascinating field of study, where the race is on to create the next big breakthrough. Let's take a moment to consider energy density. This refers to the amount of energy a battery can store for a given weight or volume. Improving energy density means longer-lasting batteries that are lighter and more compact. Imagine a smartphone that only needs charging once a week, or an electric car that can drive hundreds of miles on a single charge. That's the power of increased energy density. Next up, lifespan. This is how long a battery can continue to hold and deliver charge before it needs to be replaced. It's a crucial factor, especially for devices like electric cars or renewable energy storage systems. The longer the lifespan, the more cost-effective and environmentally friendly the battery becomes. Current research is focused on developing materials and designs that reduce degradation and increase the total number of charging cycles a battery can handle. And then there's charging times. In our fast-paced world, no one wants to wait hours for their device to charge. Rapid charging technology is a hot topic in battery research, with the goal of achieving full charges in mere minutes without compromising battery life or safety. Moving beyond the lab, let's not forget about the role we play in all of this. Proper battery care is vital in extending the life of our batteries. Avoiding extreme temperatures, not overcharging, and following recommended charging practices can all help to keep our batteries performing at their best for longer. So that's how batteries work, a world of chemical reactions right at our fingertips. From the basic principles to the cutting-edge research, it's clear that batteries are more than just a way to power our devices. They're a testament to human ingenuity and our relentless pursuit of progress.